This is a Friday Shoes production. It's lesson 12-1 in our books on page 632. Target is I can count outcomes by using a tree diagram or the fundamental counting principle. Those are the two concepts there. Let's talk about outcomes. An outcome is any one of the possible results of an action. For instance, when I flip a coin, there's two possible outcomes, a heads or a tails. Or when I roll a regular die with 6 sides, there's 6 possible outcomes. An event is an outcome or a collection of outcomes. An organized list of outcomes called a sample space can help you determine the total number of possible outcomes for an event. One type of organized list is a tree diagram, and that's what we're going to focus here first on. And let's take a look at this example and how to do one. All right, banquets. Draw a tree diagram to determine the number of different meals described in the real-world example. So at this banquet, it says, at an awards banquet for the school track team, each person can select a meal from the options shown. And the banquet menu options are, we have appetizer, soup, and salad. Then you have a main dish, which is beef, chicken, or pasta. And then dessert, you either have cake or pie. You can see on the right here, I've set up the appetizer, the main dish, and the dessert, and then also what the final outcomes are. So how many different meals can you possibly put together with these choices for appetizers, main dish, and dessert? We'll take a look. For our appetizers, if you remember now, we've got a soup or a salad that you can pick. And then for the main dish, we've got beef, chicken, or pasta. And then for dessert, we have cake or pie. So for each one of those items, how many possible outcomes are there? So we could have, if you look at it from the top, you have soup. You can pick soup, then you can have beef, and then you can have cake. But you can also have soup, beef, and pie. And that's a totally different meal option because of the switch of the cake and the pie. So how many possible outcomes are there? All you have to do is count all these up. And here's what they look like. You have soup, beef, cake, soup, beef, pie, and then you can keep going down the list. And there's 12 of those total outcomes. So there's 12 different meal options for this particular banquet. All right, you give it a shot. Pause the video, try this one, come on back, see how you do. Now it says a dime and a penny are tossed. Draw a tree diagram to determine the number of outcomes. Well, that means you got two things. You got your dime, you got your penny. And for each of them, there's a heads and a tails. So let's say you flip the dime. That's possibly a heads or a tails. Now you go to flip the penny. That's also a heads and a tails. So if you got heads the first time on the dime, you could also get a heads or a tails on the penny. Same with the dime. If you flip the tail, you can get heads or tails on the penny. So putting them all together, you can see we've got heads, 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 tails, tails, heads, and then tails, tails. So how many is that? Well, of course, that's 4 possible outcomes. 4 things are going to happen. That's all the possible things that are going to happen. And that's what the answer is to the question. All right, let's look at our next piece, which is called the fundamental counting principle. It says you can also find the total number of outcomes by multiplying, and this is called the fundamental counting principle. The fundamental counting principle states this: if event M has M possible outcomes and event N has N possible outcomes, then event M followed by event N, one after the other, basically is M times N. You take the 2 and you multiply them together, and that's how many possible outcomes there are. Now, some of you may have noticed that on the last example that we did, or I should say the banquet example, you're like, well, I can do that faster counting up examples. Let me show you what I mean. If we know how many appetizers we're having, how many appetizers we can choose from, there's 2 there. How many main dish things we can choose from, there's 3 there. How many desserts can we choose from? There was 2 there. Well, if we multiplied those all together, guess what? That's 12. And how many outcomes did we say it was? 12 outcomes. So there's a fast way to do it if you're just looking for the number, but if you're looking for the list, notice how we have all those outcomes written out. The tree diagram gives you that information. All right, so let's look at this example for the fundamental counting principle. Here's baseball. It says use the information at the left to determine how many different infield teams are possible. One player is selected for each position. All right, so here we are, baseball. And in 2007, the MLB All-Star Game, 14 players were nominated for each position in the infield: first, second, third, shortstop, and catcher for the American League. So 14 players were nominated for each of those positions. All right, so first off, we have to know how many different positions we're talking about. And we have 5 different positions we're talking there, and 14 choices for each of those positions. So to use the fundamental counting principle, each position, you have 14 possible choices. So there you are. 14 is going to be multiplied by itself 5 times. And notice that's 537, 824. You wouldn't want to make a tree diagram for this one. That would take a very long time. So there are 537,824 possible infield teams. That's a lot of infield teams that they could possibly put together with those combinations. All right. You give it a chance on this one. Pause the video. Come on back. See how you do. All right. A restaurant offers a choice of 3 types of pasta with 5 types of sauce. Each pasta entree comes with or without a meatball. How many different entrees are available? How many different ways can you have these meals put together? Well, you do see this. You see we've got 3 types of pasta, 5 types of sauce, and then, of course, we have with or without a meatball. That's 2 choices there. So there we are. We got pasta, sauce, and meatball. And pasta is 3 choices, sauce is 5, and the meatball is 2. Then we would multiply those together, and you get 30. So there are 30 different meals available. All right, last piece. It says outcomes occur at random if each outcome is equally likely to occur. In this situation, the probability of an event is the ratio of the number of outcomes in that event to the total number of outcomes. So again, probability is just taking the ratio of the number of outcomes in that event to the total number of the outcomes. All right, let's look at that in a little bit more of a real world example. It says students at East Valley Middle School take 6 classes each day: math, science, social studies, English, Spanish, and music. Looks similar to ours. We have 6-period day. What is the probability Julio's first 3 classes are science, music, and math in that order? So just his first 3 classes. Well, first off, we got to find the number of possible outcomes. How many possible ways, combinations of classes can he have in those first 3 classes? Well, let's take a look at the classes themselves. Excuse me. There we go. Math, science, social studies, English, Spanish, and music. Those are the 6 classes. All right? Let's take a look now. We need to find the first 3 classes. So when we go to fill in what he's going to have for that first class, and that's that first box, how many to do the math to find the outcomes, we have to figure out how many choices he has. How many choices does Julio have for that first class? So randomly selecting, how many choices does the computer have, or does he have when he's picking through this? Well, he's got 6. Take a look at them all. There's 6 classes right there. So he's chosen, let's say he wants to have, of course, the science first. So let's say, okay, we had 6 choices. Now science is out of there because he's chosen it. It's out. Now you go to the next number and think about how many choices he has for that second class or second period. Well, he's got 5 choices now. He's got to fill in with one of these. So he wants to have music. Okay, so he fills in with music. Let's see if it will actually pop up for me. I'm trying to cross that off. I don't know why it won't do it. There it is. So now it's crossed off. So he had 5 choices. Now he's down to how many choices? That's right. He's got 4 choices left. And of course, he wants to take on the math. Now, these are the 3 classes that he wanted to figure out, the first 3 classes. He had 6 choices, 5 choices, 4 choices. As he was selecting, he had to reduce that number by 1 because he kept taking one out of the pile. So take 6 times 5 times 4, and that is 120 choices. That's 120 ways that you can write that. There are 120 possible outcomes. So there is one way Julio's class can be science, music, and math in that order. So we would say that the probability of having science, then music, then math is 1 out of 120. There's one order that works that way out of the 120. So this can also be written as a percent, and take a look. It's 0.8%, less than 1%. So we would say that is very unlikely to happen if it's done randomly. All right, how about this? 2 number cubes are rolled. What is the probability that the sum of the numbers on the cubes is 12? You try it on your own, and then this will be our final one. All right, first off, you have 2 number cubes, right? All right, so we have cube 1 and cube 2, we'll call them. How many possible outcomes are there? That's the first thing you want to do. How many possible things can happen when you roll 2 cubes? Well, doing the math, we get there's 6 outcomes on the first cube, and there's 6 outcomes on the second cube. So using the fundamental counting principle, we're just going to multiply those two together, and we'll see that there's 36 possible outcomes. Now, how many of those outcomes have a sum of 12? Well, there's only one outcome, and that's when you roll 2 6s that has a sum of 12. There's only one of those outcomes. Hence, the top of your fraction is going to be 1. Here's what it says. There is a 1 out of the 36, or 1 in 36 chance of rolling a sum of 12. So the probability is 1 over 36, or if you use that as a percent, it's going to be about 2.8%. You have a 2.8% chance when you roll 2 dice to get a sum of 12. All right, for better understanding, don't hesitate to rewatch the video or read the examples in the book, or you can also watch the personal tutor videos online in the online textbook. And as usual, this has been a Friday Shoes production.